Well, thank you very much, Mr. Sankaran, for joining us tonight to speak a little bit about innovation to our FTC team, the Gearheads. We've got a short introduction that Avanish is going to lead us through tonight, just to give a little background information and give you a little bit more context. We've got about 15 members of the team with us here and an additional 7 or 8 people online. We'll watch and see how that grows, but thank you very much for joining us tonight.
Yeah, my pleasure.
All right.
Okay. Good evening, everyone. Yep, my name is Avanish, and I'm a sophomore at Brookfield Central High School and a part of the FTC Gearheads team. So as Mr. Newstad mentioned, we're incredibly excited and grateful to host today's keynote speaker, Mr. Vijay Sankaran. We'll start this evening with a brief introduction to FIRST program. And as we progress through the speech, feel free to submit any questions that you guys have to the Q&A tab of the webinar, and we'll try to answer all of them in the end. And so starting with the introduction of FIRST. So FIRST is an international robotics program that gives kids a platform to explore and dive into STEM. Kids get a chance to design, program, and operate robots that compete in a head-to-head format. FIRST is widespread in Wisconsin, and about 4,248 kids participating in total along the 4 groups of FIRST: FLL Explorer, FLL, FTC, and FRC. FIRST has grown tremendously in Elmbrook also, with 242 kids participating in total, along 12 FLL teams, 5 FTC teams, and 1 FRC team. So, Misha, do you want to talk about our first theme today?
Yeah, so for our first theme this year, FIRST teams across our programs will reimagine the future of sustainable energy and power their ideas forward. And it was based on the UN sustainability goal of focusing on ensuring access to affordable, reliable, sustainable, and modern energy for all. And as we are innovating, we are very excited to introduce Sankaran from Johnson Controls to talk about disruptive innovation.
So I'm just going to give a brief bio of Mr. Sankaran. So Mr. Sankaran is currently working for Johnson Controls as their Vice President and Chief Technology Officer. In this role, he leads a global organization of 2,500 software engineers and technologists, which with responsibility for software engineering, for building management systems across video surveillance, intrusion, access controls, and controls, as well as a recently launched Open Blue software program. He also has over 25 years of work experience in multiple well-known companies such as Ford, TD Ameritrade, and Johnson Controls. So over to you, Mr. Sankaran, for your speech on disruptive innovation and sustainability. Thank you so much.
Thank you very much for having me, and I'm glad that we could spend this time together. You know, I went to MIT for my undergraduate degree, and I got a degree in computer science a long time ago. And so I remember, you know, MIT hosts one of the most famous robotic competitions in the world. It's called 6270, and basically teams from all over the world compete to, you know, earn the recognition of having the best robotics on the planet. And back in those days, which was the mid 1990s, you know, there, you know, wasn't as prolific a set of robotics teams and high school and all across the country. And I know how passionate people are about STEM and robotics these days. So it's really exciting to see how passionate that all of you are about innovation and technology. That's really been, you know, my lifeblood, you know, throughout my entire life. And maybe, you know, before I get into what we're doing at Johnson Controls, you know, I can start with just a little bit about myself. I've always been passionate about technology since the time that I was a little kid in elementary school. And, you know, I remember getting my first Apple II computer that was, you know, back in the mid 1980s when Steve Jobs first became the CEO and founder of Apple for the first time. And I remember just spending all day and all night on that computer, learning about technology, learning about software, learning about programming. And, you know, that was a passion of mine all throughout high school into college, where I got my degree in computer science. You know, what's really fueled my motivation is how we can leverage technology to solve problems in the world. And that's why I'm so excited about what we're doing at Johnson Controls. I really believe that technology in and of itself is very cool, but technology, when utilized to solve problems, is even cooler. And so that's why I'll spend a little bit of time talking about technology in buildings, why it's so cool, why it's so important. I believe that our next big, great challenge on this planet is global warming. And I'll talk a lot about what Johnson Controls is doing, leveraging its OpenBlue platform, which I lead, to address some of the issues around global warming. And then after I give a short presentation, I'll leave it open for some Q&A for each of you. So that's what we'll do. Let me figure out in this how I share my screen. Okay. It says I cannot share my screen.
Okay, just 1 second, and we think we can get that straightened out for you.
Yep.
Okay, try one more time, please.
All right, there we go.
Okay, perfect, that's working.
All right, wonderful. Okay, is everybody able to see my first slide?
Yes,
Yep.
we can see it.
Okay, wonderful. So, really what we're trying to do here at Johnson Controls is leading the evolution towards smart, healthy, and connected buildings. Johnson Controls, you guys are all in the Milwaukee area, has been around for a very long time. In fact, since 1885, when Warren Johnson, who is the founder of Johnson Controls, invented the first thermostat. And since then, we've had a lot of different types of businesses, whether it's automotive or batteries or anything else, but really there has been this constant thread and focus around buildings, spaces, people who work in those buildings. And our digital platform, OpenBlue, is really oriented all around that. So this is what motivated me to come to Johnson Controls. I got here about 19 months ago. And like I said, the big challenge that your generation will face is global warming. And, when I read Bill Gates's book around global warming about 2 years ago, the fact that 40% of all global carbon dioxide emissions are generated from the building sector, whether that's from the HVAC systems inside the buildings, or whether it's from lighting, or whether it's from the consumption of electricity that's powered upstream, or the building materials. That's a pretty significant number when you think about it. And just the opportunity to leverage technology to chip away at that is a pretty special and motivating thing, and really why I'm at Johnson Controls. And we're doing that really through, a couple of different lenses. One is by introducing new products and solutions. We have a very extensive industrial products business. So by embracing electrification through things like heat pumps or other electric technologies or solar panels, as well as our sustainability business, which actually goes into schools like the ones you're in, and basically we'll say, okay, how much carbon is being generated in your school district? How can I upgrade the technologies to improve that in order to really trim the emissions that come out of those facilities and get schools and higher education to net zero? It's powerful. And then that's all being driven through digital capabilities, which is where I'll spend the most of my time discussing. So if you think about buildings, and I know buildings don't seem that interesting, historically, you're like, okay, the buildings cool the buildings, they heat the buildings, you have fire detection in the classroom with sprinklers, you have access controls to get in and out of buildings. All of them seem pretty pretty boring and not intended to do much individually. But if you think about it, what do each of these systems generate? It's data and information. And when you put all of this together, you can create, a smart autonomous building. So think about your robotics where you have these robots that are sensing around you and they're looking for walls and they're looking for objects and so on and so forth. You're building autonomous robots. Or, I come from the automotive industry, cars that can sense objects near them, can detect them, that can move around. And those are all cool, but they're a really hard problem to solve because especially with automotive and smart vehicles, smart autonomous vehicles, there's so many different conditions that you have to correct for. I was on a long drive this past weekend to Cleveland, and the number of, different road construction events and different kinds of traffic patterns and things like that makes it really difficult to have smart autonomous vehicles. But smart autonomous buildings, on the other hand, are definitely doable in the sense that if you think about taking in information from the different aspects of the building, whether that's HVAC or fire or access, and being able to bring all of that data together, into a cloud, and being able to run artificial intelligence and machine learning models against that makes recommendations in real time to either heat the building or cool the building or turn off lights or give you space utilization metrics. That all holistically, enables you to generate and create a smart autonomous building, which is what we're in the progress of doing right now. So it's pretty exciting when you think about all of this coming together, and I'll talk about the components that bring together this smart autonomous building. Unlike autonomous vehicles, which I still feel are about 10 to 15 years away, a smart autonomous building is less than 5 years away, because the good thing about buildings, last I checked, is that they don't move that easily. So you don't have to worry about a lot of the conditions that cars have to worry about. But it's pretty exciting as you connect all of these, from smart elevators to space controllers and building controllers and security, to create a smart autonomous building as we go forward. So if you think about all of the things that you can get data from a building, it's your traditional HVAC systems. Many of you probably don't realize, but there's either a chiller that is cooling your facility, or you have a boiler that's heating your facility, or a rooftop unit that's providing ventilation. You have what's called a building control system that controls all of those different devices and thermostats and valves and different things in your facilities. You have fire detection systems that are probably at the top of the roof in your classroom. And then you have security systems, which keep you all safe. And all of these things provide input into our enterprise smart buildings platform, OpenBlue, which captures data in a cloud using our advanced edge technologies, and then creates a set of applications that help drive energy management, understanding of how that space is laid out through the use of what we call as a digital twin, asset health management, smart metering, predictive management, and then driving a number of different outcomes across our customer base around everything from sustainability to workplace productivity and space utilization to safety and security, where depending on the threats, you can notify different people. Our solution right now has actually been deployed throughout the world. And if any of you are soccer fans, it's actually been deployed right now at the FIFA World Cup in Qatar, where they're managing all 8 buildings simultaneously using our visual digital twin software to tell them exactly what's going on in real time in all of those buildings, using different cameras and access and different alarm points and things like that. So it's pretty powerful what you can do with this data across the building. And then you just take that data and then you can marry it up with other data that's more publicly available. So things like weather data, health and wellness data about the indoor air quality in the space, being able to connect that to work order management systems. So, you can think about what we're trying to do with OpenBlue as basically a data mashup with a bunch of different data coming in inside and external to the building, adding analytics and artificial intelligence on top of that, and delivering different outcomes around sustainability, energy management, asset management, and I'll talk about these in a little bit more detail. So if you double click on it, the middle layer, our OpenBlue Enterprise Manager, which I'll go through in a lot of detail, is where the magic happens in terms of the outcomes that our customers consume. And I'll walk through each of these. And we deliver a number of different solutions, whether they're specific to a particular type of asset, whether that's a chiller or it's for a particular different industry like K through 12, or to really support our sustainability business. And then we have a couple of foundational capabilities, our edge capabilities and our cloud capabilities that I'll talk about in 1 second. But if you look at, the kind of the key building blocks of what OpenBlue is all about, it's really about a secure and intelligent connected edge. And so what does that mean? So in order to connect to all these devices and basically capture data from them, you need to have a device, on-prem that can connect to a lot of different protocols, basically ingest different data from those protocols, apply data standardization against that, as well as, connectivity securely up into the cloud. So we've really invested a lot of time and money in building that connectivity from edge to cloud. And then we have a multi-tenant cloud environment, which means that multiple customers run in our cloud environment at the same time. That allows us to get all of the upgrades at the same time. We have a digital twin data model, which basically is a database that takes all of the assets that are inside a building and standardizes it in a common way and tells you like what all the equipment is in a given classroom versus another classroom. And then we actually put that into a visualization engine where you can digitally actually see your school using CAD software, and then be able to drill down into it and see exactly what equipment exists in different places in the school, and put alerts on top of that and things like that. And finally, artificial intelligence, which is a big part of our solution. It is the thing that takes all of this data and really understands different kinds of interrelationships in the data to do predictive forecasting and optimizations and clean air and space utilization and things like that. And I'll show some examples of that as we go forward. So our OpenBlue Enterprise Manager really is what delivers all of our solutions, and it has a number of different modules associated with it. Everything from Sustainability Manager, which is our most important module right now, to a number of different other areas, but I'll go through all of these at a high level. And so this is what our customers see when they come into OpenBlue Enterprise Manager, and you can see all of those different modules in the upper right. Basically, if you were a customer with a lot of different properties, you'd see pins for all those properties that exist across the world. You can see that on the Energy Manager part of the screen, you can see what the total electrical consumption is across all of your buildings. What is your water consumption across all your buildings? It tells you where you need to have attention because the electrical consumption may have increased. And we'll go through all of these in detail around what are the faults and things like that. But you can see on a single pane of glass all of your buildings, and then you can drill down into more details as you go forward. And so these are all the different pieces you can see on the bottom right. If you want to compare all of your buildings, you have a number of different buildings there. You have what's called a chiller plant, which is how your building gets cooled. And then it tells you how the efficiency is. And then you can look at all of the different KPIs at the top for your building. What's your electrical energy? What's your thermal energy? And basically look at all of these and compare them across different baselines. And you can visualize it, as you can see in the middle, with a visualization as well, showing that how things work. And so then, the other piece of this is that you can bring in all kinds of data into Enterprise Manager that allows you to fully pull together a full 360-degree view. We also have a mobile app called Companion, which are actually our employees or users can bring into the facility and book rooms, adjust temperature and conditions inside the rooms, and do all of those different things. So it's pretty powerful in terms of the overall end-to-end view of what we can do with all of these capabilities across the enterprise. And then you can see all of the pins that we talked about, what the cooling is, and so on and so forth. So this is where everybody starts. These are the different categories. And then you can go into Energy Manager at a next level of detail. And then, here's some specifics around, let's say that you're an energy manager. You can begin to look at, okay, what is, the electrical usage at one of my sites? What is my savings against the baseline that I set? What is the total carbon footprint that's been generated from that facility? And then you go to the right and you get down to more details around, what's been the patterns over a period of time using like advanced visualization software and things like that. And this is what the AI can help with too. We have a lot of AI algorithms that says, okay, based upon the fact that it's going to be hotter next week or cooler next week, how do I adjust my the power of my different equipment in the building so that I can either save energy or I can make it cooler, depending upon what the pattern of people might be working inside that facility. So it's really great how all these variables fit together in terms of delivering overall value. This is a new experience that we've launched recently called our Sustainability Manager, which actually is our net zero advisor. And so if you think about a lot of buildings, where they really want to understand is taking data from energy, utility bills to understand what the composition of the energy that they're using is, and then create a single pane of glass called Net Zero Advisor that talks about scope 1, scope 2, and scope 3 emissions. So scope 1 and scope 2 emissions are those emissions that that you create in a building directly through the electricity that you get, as well as the types of equipment that operate in your building. And then scope 3 is what other people generate on your behalf. So things that you buy from third parties like paper or desks or computers, and how much carbon that they generate on your behalf. And so the idea here is that you want to get, if you say net zero, you want to figure out, how do I look at all of those different data points so that I can get it to zero, thereby reducing, contribution to carbon emissions and hence global warming. And so you can see, like, if you look at different energy and what's sort of your demand curves, and figuring out how to adjust your demand curve by using alternate energy sources like solar, for example. You want to smooth out these demand curves as you go forward. And then going into our net zero advisor, this is what tells you, if you look at the upper left where it's pointing, like, what is the total emission? How much emission did you reduce since the beginning of this year? What's the net emission that's left? So it's a tracker basically for companies to measure their greenhouse gas emissions, and being able to set targets and correlate that with specific buildings. So this is actually Johnson Controls portal. We actually have an opportunity to basically map out our path to net zero over time. And so it's really important that, we have announced, commitments to be net zero by 2035. How are we actually getting there across all of our facilities? And so right now we have just recently launched a module around goal and target setting, which allows companies to set targets and goals for net zero, what time frame, how much, so that corporate sustainability offices can actually measure the compliance against this. And then finally, what we want to get to by the end of this year is to understand what faults in a building or diagnostics against particular equipment is showing that we're not able to achieve net zero because of certain reasons, certain equipment that's running suboptimally and things like that. So it's all really very exciting to see how all of these are coming together to help drive a company to net zero targets. And then if you look at, another big piece of it, this is assets. So what are all the assets that exist in your building? How many different types of assets do you have? What's the age of it? Where are they located? What are all the faults associated with the assets so I can diagnose it? What's the trends? Is it getting worse? Are which devices are actually faulting more than others? So it gives you sort of a full view of all of the equipment types that exist inside the building. And then you can see all the details that you can see on an asset. What's all the relationships between the different equipment? What's the spaces that's been served? You can send emails based upon that. So it's really, really interesting and exciting around how all of this comes together. And then, what is the cost of that too? If you were able to, understand where the faults are, how do you basically resolve them and save costs, because that's a big driver for a lot of companies in terms of having lots of different types of real estate. So it shows you what the costs of having different faults are as well, and how long an equipment was down. So for example, if a chiller was down for a certain point in time, there's significant cost, like because you may have to evacuate a wing in a hospital, for example. So how does that all come together in terms of driving, cost optimization opportunities? This is now moving into space utilization. So you can see how space is being used across a building. Basically, you have the layout within a particular space and what are the different equipment in it. And then you can see as you go to the right, how that space is actually being utilized in terms of the density of different people using particular spaces. And then you can see here as well, just around space performance, different meeting rooms, how well they're being utilized. Now with a lot of people finally going back to work in facilities, they want to understand how they can optimize the footprint of those facilities. So that's all pretty cool to see how everything comes together in terms of the utilization of the space as well. And then here, this is our green kiosk. So we can do kiosks inside of buildings where you can touch the screen. You can look at the energy in a building. This is actually for a large building, an iconic building that we built in the Middle East. And you can see it gives you all these different emissions. You can get themes and really customize the dashboard for what different employees might want to see. Then moving along, you can also manage for companies that are real estate companies and that lease their spaces. For each company, each renter, right? They can look at what the tenant is consuming. So real estate companies can actually use our tool to basically measure how each tenant is consuming parts of their facility. So they're also a big customers of ours, and they can use similar analytics, using our tenant manager product. And then this is really cool because this we developed during COVID. There's actually a white paper written at MIT that showed that by ventilating a space more, when there are a lot of people there, you can actually reduce, the spread of infection in a particular space. By turning it up. So if you look on the right, we're using what's called a multi-solve AI engine. And basically you're looking at, okay, here's the kind of filtration I have. Do I have room disinfectant? And then it gives you a bunch of choices. So basically it said, okay, I can improve infectious diseases, we can reduce the spread of infectious diseases and autonomously change the settings inside of the building, but it's going to cost you more money, right? So you may want to do that when there's a lot of people in the space. But if nobody's occupying the space, maybe you want to go all the way down to the right because you want to save money because there's nobody in the space. So you can use this performance advisor to, in real time, basically adjust, what's important to you in the space based on a balance of of different things, both energy and other pieces. So it's really cool, to see how you can manage the health of a space as well as the efficiency of the space using AI and data and analytics. And then here, again, is more around space performance and then indoor air quality. So you can look on the right and see how you can look in each of these spaces. What is your indoor air quality score? What is your IAQ score? Your IAQ score is basically your indoor air quality score. What's your energy cost per month? How much of that is against your budget? And then some KPIs around, the health of your space too. So we also address really using that same data, healthy buildings in a particular space. And then here are some comparative reports. This is all around chillers. How does your chiller performance compare to other chillers in your facility? What are the faults that are associated with those chillers? Chillers are an incredibly important asset for Johnson Controls and for our customers. A chiller costs anywhere from $150,000 to well over $1 million, and is what most companies use to cool their spaces. So if one goes down, it's a pretty big deal. And so we have a connected chiller solution that basically looks at all of the different faults and allows our technicians to manage those chillers much more effectively. And then there's a bunch of different checks. You can see upper on the left here, our chiller performance index score, and a bunch of different algorithms that we're deploying around chiller stability and chiller efficiency using AI and ML to really optimize the performance of the chiller. A chiller constitutes about 30% of the energy that gets utilized in a building. And so it's a pretty big chunk. And so optimizing it for both efficiency as well as sustainability is pretty important. So in summary, and now turn it over to open it up for some questions. We really are focused around building healthy spaces, a healthier planet, driving it through sustainability and energy. And so, what we're doing is pretty powerful here at Johnson Controls. And I'm super excited to be a part of the team. And I'll stop there and open it up for any questions.